So the title of section 5.2 is factoring by grouping. For the rest of the chapter, or at least for most of the rest of the chapter, we're going to learn different techniques to factor problems, or to rewrite polynomials into the product of polynomials, and it's going to be hinged a lot on the design of the problem. The technique we're going to learn in section 5.2, called factoring by grouping, I almost exclusively only use when the problem has 4 terms. There are times that a problem will have 3 terms. I'll rewrite it so it has 4 terms so I can factor by grouping. But if the problem doesn't start with 4 terms, or I can't easily turn it into a problem with 4 terms, the technique I'm going to use today I wouldn't use. And I have to take great care to set the problems up. If I just randomly wrote down a problem with 4 terms, the technique of factoring by grouping, it's probably not going to work. So these are really carefully selected problems. My problems that I wrote up for examples, I'm not that excited about. So I'm going to try to teach you factoring by grouping using the steps that they have written, that I have written, without showing my examples, because my examples, I don't know what I was thinking when I wrote it. They're fine, but it's not really how I factor, and boy, might as well teach you how I instinctively factor. They're equivalent, the methods, but this is going to be better, I hope. So, anytime a problem has 4 terms, my gut tells me I'm going to factor by grouping. And to factor by grouping, my first step is to form 2 groups of 2 terms. What I'm going to do is take the 4 terms and make groups of 2 and capture those groups of 2 in a parentheses. So I made 2 groups of 2, took the first 2 groups and made a grouping with them. The second 2 terms made a grouping with them. So first group, first 2 terms, second group, the second 2 terms. Now I'm going to revert back to section 5.1. I'm going to greatest common factor factor the x squared plus 3x. If in section 5.1 I asked you to factor x squared plus 3x, you would probably say, well, the coefficient of the x squared is a 1, which has a factor of 1 times 1. The coefficient of a 3 has factors of 1 times 3. My greatest common factor is not going to have a number because the only common factor is a 1. And then you'd look between the x squared and the x. They both have an x term, and you would take the smaller of the exponents. And that's what I'm going to do. I'm going to factor out an x from the x squared plus 3x by taking an x away from each and putting what's left inside a parentheses. So from the x squared, I'll take an x away. I had 2 x's. I took 1 away. I'm left with 1x. From the 3x, when I take an x away, I'm left with a 3. So I'm in the world of factoring out a greatest common factor from each pair, step 2. Now I'm going to look at the pair of 4x and plus 12. I'll look at the coefficients. The coefficient of 4 has factors of 1 and 4, and 2 and 2. The factors of the number 12 are 1 and 12, 2 and 6, and 3 and 4. So the number part of the greatest common factor from 4x plus 12 is 4. And then I don't get a variable for that factoring specifically because the second term doesn't have an x. So after my plus sign, I'm going to factor the 4x plus 12. I'm going to put the common factor of 4 in front of a parentheses, and then inside the parentheses, I'm going to put what's left after I factor out a 4. To figure out what's left, I divide each term by 4 in the second parenthesis. So I'll do 4x divided by 4. The 4's will cancel, become a 1. I'm left with an x. The 12 I'll divide by 4 and get a 3. Now we have the problem set up like the problems at the very end of section 5.1, and I'm going to factor this using the x plus 3 as my common factor and create a second parentheses, and in it, put the terms that are left in front of the parentheses. I claim this is my answer. Multiplication is commutative, which means I can write my answer in two separate ways. Saying the answer is x plus 3 times x plus 4 is equally correct as saying the answer is x plus 4 times x plus 3. They're both correct answers because multiplication is commutative. If I wanted to check, it turns out that the checking is easier if I write my answer in the second form. Let me show you that my answer checks. Anytime I factor, I should be able to clear the parentheses and match up somehow with the original problem. So here I'm going to check by foiling. I'm going to do the first, which are x times x. That's going to give me an x squared. I'm going to do the outers, which are x times 3. That's a positive 3x. I'm going to do the inners, which is positive 4 times x, which is positive 4x. And then the last, which are 4 times 3, which is positive 12. I don't know how readable this is, but this is exactly the original problem, so I know my answer is correct. I could have checked this and then combined the 3x and 4x and got x squared plus 7x plus 12, combined the 3x plus 4x in the original problem, made the rewrite of my answer equal to the rewrite of the original problem if I wanted to check that way. So I'm going to continue doing this factoring by grouping, and the big trick in factoring by grouping is when this sign is negative, it winds up, I'll have the need to factor out an opposite. So let's do 3 together. My 4 is a little low on the screen. I'm going to start off, first step, I'm going to form two groups of 2. For number 3, I'm going to put the first 2 terms in a parentheses, and the second 2 terms in a parentheses. The variation in this problem compared to the last problem, when the second sign in the problem is positive, I put it in front of the second parentheses. When the second sign in the problem is negative, I put it inside of the second parentheses. That's one of the big tricks, maybe the only big trick in this section. So I formed first group and a second group. Now I'm going to GCF factor each, and I'm going to start to factor in my head just to speed up the process. So between the x squared minus 5x, because the x squared has a coefficient of 1, the numerical part of the common factor is going to be 1. I'm not going to write it. Both terms have an x. I take the smaller exponent. I'm going to factor out an x. So first parentheses, I factor out an x. First term, the 1x squared, I'll take away one of the x's and be left with an x. After the minus sign, I'm going to factor out the x and be left with a 5. Just because maybe this is a little more complicated. For the negative 2x plus 10, I'll look at the coefficients. Worry about the sign in a second. The coefficients are 2 and 10. The number part of my common factor for factoring out 2x plus 10 is going to be 2. The first term has an x, the second term doesn't have an x, so I don't get to factor out an x. Because the first term is negative, I'm going to factor out the opposite of the greatest common factor. I'm going to factor out a negative 2. And when I factor out a negative, I have to switch the signs. So to figure out what goes in front of the parentheses, because I factored out a negative, the first term was negative, it's going to turn to positive. Because I factored out a 2, I'll divide that 2 by 2, which will turn it to a 1. I'll be left with an x. So I'm left with positive 1x, which I'm just going to write as x. Next term, the positive 10, because I factored out a positive, because I factored out a negative, I'm going to switch the positive sign to negative. Because I factored out a 2, I'll divide the 10 by 2 and be left with a 5. So right after my first factoring, I'm going to put the result of this factoring, minus 2 times x minus 5. Now I'm basically done, other than if I want to check. So I'm going to write the common parentheses first, x minus 5, and then I'm going to follow up by what's in front of the common parentheses and put that in its own parentheses, which is going to be x minus 2. That's a correct answer. For checking purposes, the bottom one is better for checking, but these are both correct answers. A lot of times in this section, my work and your work may give the same answers, but our parentheses are reversed. That doesn't matter. This will be the last problem I check just because of the time factor. So if I wanted to check, the flipping version is better for checking. I'm going to check by foiling. I'm going to go x times x, which is x squared, and then x times minus 5, which is minus 5x, and then minus 2 times x, which is minus 2x, and then minus 2 times minus 5 is positive 10. That's exactly the original problem, so I've checked perfectly. So I'm going to work on number 6. Anytime a problem has 4 terms, my gut is to factor by grouping. I'm going to put the first 2 terms in a parentheses. I'm going to plug the second 2 terms in a parentheses. If the middle sign is positive, it goes between the parentheses. If the middle sign is negative, it goes inside the second parentheses. Now in the first parentheses, I'm going to pull out the common factor, and now I'm just going to start doing common factoring in my head. I need to write the problem down right. I forgot the 3 in front of the 6 in the second parentheses. First parentheses, I'm going to pull out a common factor of an x. First piece had 2 x's. When I take 1 x away, I'm left with 1x. After the minus sign, if I factor out the complete term, I need to leave a 1 behind. Second parentheses, both numbers have a 36. Both terms have a 36. 36 is going to be the common factor. And so if you need to pause the video and find the common factors more, with more steps, then do it. But I'm just going to do the common factoring in my head just to save a bit of time. To figure out what goes inside my second parentheses, I just divide the numbers by 36. The first 36, if I divide it by 36, I get a 1. I don't need to leave the 1 because I'm going to have the x left over. After the plus sign, when I factor out a 36, technically I divide the 36 by 36 and get a 1 again. If after the GCF factoring step you don't have common parentheses, then either this doesn't factor or you made a mistake. It doesn't factor using grouping. In this section, all the problems will factor using grouping. So if yours doesn't factor, if you don't get duplicate parentheses, then you've made a mistake. And when you write your answer, it doesn't matter the order that you choose for your answer. One of my parentheses is going to be the common parentheses. The other parentheses is going to contain what's in front of the common parentheses. Let's do 7 together. So for 7, I'm going to put the first 2 terms in a parentheses. If the middle sign is negative, it goes inside the second parentheses, and I have to factor out a negative. First parentheses, I'm going to pull out a common factor of x. Be left with an x minus 9. And for that negative 4x plus 36, the common factor would be 4. Greatest common factor would be 4, but I'm going to factor out a negative because the first term is negative. And when I factor out a negative 4, signs flip and I divide by 4. The negative 4 is going to turn to positive 1. I'm going to change the negative sign to positive because I factored out a negative. I'll divide the 4 by 4 and get a 1. I'll leave the x. For the plus 36, sign's going to change to minus because I factored out a minus. I'll divide 36 by 4 and get a 9. Now I just write the answer. And I'm just going to start writing it in one order, but the orders are always invertible. And for checking purposes, the inversion is usually best. I'll probably start doing one problem on each page rather than doing both. And I think 12 for me is harder than 10. So I'm going to do 12. In 12, first two terms in a parentheses, y squared minus 6y. If the second sign is negative, it goes inside the parentheses. If the second sign is positive, it goes in front of the parentheses. Created my two parentheses. Now I'm going to, in my head, common factor, factor. First parentheses, I'm going to pull out a y as my common factor because both terms have a y and y to the first is a smaller exponent. I'm going to be left with y minus 6. Second parentheses, because the first term is negative, I need to factor out a negative. 5 is the largest number that goes into 5 and 30. I'll factor out a 5. Both terms in the second parentheses don't have a y, so I don't get to have a y as my common factor. Now I'm going to switch the signs and divide by 5. First term went from negative to positive because I factored out a negative. I'll divide the 5 by 5 and get a 1. I'll leave my y. Second term had a plus sign in front of it. I switched the sign because I factored out a negative. I'll divide 30 by 5 and get 6. And I can write my answer. And of course, anytime you write an answer to a factoring problem that has two parentheses, there really isn't even a preference. You can write the answer in either direction. I like beating on the negative ones. Let's do 15 together. I'm just going to do one problem on each sheet. Maybe I'll do one of yours and one of mine. So for 15, 5x squared minus 5x in the first parentheses, negative 6x plus 6 in the second parentheses, and then greatest common factor each. This is why that greatest common factoring skill was taught first, because it's going to come up again and again and again. First parentheses, I'm going to factor out a 5 along with an x. Divide by 5, take an x away and be left with an x minus 1. That's the part where I'm not explaining to save time, but it was where you might need help, so you might want to dig back into section 5.1 if that doesn't make sense, because you've got to get the common factor factoring down in this chapter. Second parentheses, it leads with a negative, so I'll factor out a negative. Both terms have a 6. I'm going to factor out a 6. Both terms don't have an x, so I don't get an x. I'm going to change the signs and divide by 6. The negative 6, I'm going to change to positive to start. I'm going to divide by 6 and get a 1, leave the x. Plus sign in that parentheses is going to flip to minus. The 6 is going to turn to 1 because I factored out a 6. I divide 6 by 6 and get a 1. For an answer to 15, x minus 1 times 5x minus 6. There's kind of nothing new, but there's some tricks. And One of the tricks shows up on problems 19 and 20 and 17 and 18. Let me do 18 so I'm not factoring out negatives every time to show you the trick. Or one of the tricks. That might be the only trick that's left. In 18, the middle sign is a plus. It goes between the parentheses or in front of the parentheses. I don't know what verbiage you want to use, but it doesn't go inside the parentheses. First parentheses, the biggest number that divides evenly into 4 and 12 is 4. I'm going to put a 4 in front of that parentheses. Both terms have a y. I'm going to take the smaller exponent of y to the first. I'm going to divide by 4, take a y away, and be left with y plus 3. In the second parentheses, both terms don't have a y, so I don't have a variable for my common factor. And the y has a coefficient of 1. The biggest number that divides evenly into 1 and 3 is 1. I don't have a common factor, but I need something written in front of my parentheses. And when there isn't a common factor, I say 1 is the common factor. And I put a 1 in front of my parentheses, and then I just rewrite the parentheses. That's the next big trick, is having the need to factor out a 1 for a common factor so the method works. Now I'm going to write the common parentheses along with what's in front of the common parentheses. Again, that second parentheses, I'm filling up with what's in front of the common parentheses. And of course, anytime I factor, the order that I write the parentheses in, if there's two parentheses, it's completely up to me. I just normally, I'm consistent, but you can flip-flop if you need to. Let's do 23 together. So in 23, I'm using grouping because the problem has 4 terms. If the problem didn't have 4 terms, or I couldn't change it to have 4 terms, then I wouldn't use grouping. Put the negative inside the second parentheses. First parentheses, I factor out a z. I'm left with a 2z plus 7. Second parentheses, it leads with a negative, so I have to factor out a negative. It doesn't have a common factor, so I'm going to factor out a 1, because 1 is my GCF. And now I'm just going to change the signs because all I've done is factored out a negative. The negative 2z, I'm going to make positive 2z. The negative 7, I'm going to make positive 7. If I don't get a common parentheses, especially in this section, then you've made a mistake. So for my answer, one of the parentheses needs to be 2z plus 7. The other parentheses needs to be z minus 1. And the order that you write your factors in is not terribly important. Just so you don't have so many homework problems, let's do 27 together. 27, first 2 terms, x cubed plus 6x. Second 2 terms, 3x squared plus 18. The plus sign goes between the parentheses, not inside the second parentheses. First parentheses, I'm going to factor out an x. From the x cubed, when I factor out an x, I take 1x away, I'm left with 2 x's. From the 6x, when I take an x away, I'm left with a 6. After the plus sign, Inside the second parentheses, I don't get to factor out an x because the 18 doesn't have an x. I get to factor out a 3 because 3 is the largest number that goes evenly into 3 and 18. I'm going to divide by 3 to fill up that parentheses. Be left with an x squared plus 6. And then I write my answer. In this section, mostly everybody gets the same order of the parentheses, but in the next sections, it's real common to see variations in the orders. Let me do 32. Just doing one problem on each sheet here, specifically because there's nothing new. It's just very repetitive. If you can common factor, then this is not bad stuff. If you're not good at common factor factoring, then you need to get good at it before you really dig into this. My second parentheses, not only did I put the negative sign in it, I put a 1. I don't know why I did, but I like the 1 there, so it makes me see the common factor better. In 32, from the first two terms, x cubed and 9x squared, I'm going to factor out the smaller of the exponents on the x's, x squared. From the 3 x's, from the x cubed, when I factor out an x squared, I'm left with 1x. From the 9x squared, I'm left with a 9. Second parentheses doesn't have a common factor. Both terms don't have an x, and when you have a coefficient of 1, you're not going to get a numerical common factor. The second parentheses leads off with a negative, so I'm going to factor out a negative. And if there's not a common factor, I also factor out a 1. Factoring out a negative 1 just causes me to switch the signs. The negative 1x is going to turn to positive 1x. The negative 9 is going to turn to positive 9. And that's going to leave me with I don't really know what I'm doing 32, duh. When I'm left with 32, I get x plus 9 times x squared minus 1. If you're super advanced, you probably shouldn't have been in this class, but we'll learn in section, I think it's 5.5, that could be simplified into 2 parentheses. It's a different technique that we learn for factoring 2 terms that are specially set up. So I'm going to put an or here, and if you instinctively wrote that x squared minus 1 can factor, well, you're way ahead of the game. This is going to be an easy chapter for you. Nobody needs to know this, but just because this does work, I feel obliged to show you that, oh, you could actually do that. This is the answer right now that everyone should get. This would be the answer at the end of the semester, at the end of the chapter. Maybe one more. I'll sneak one of your problems. Let's do 35. So for 35, 7t cubed plus 5t squared, I'll throw in the first parentheses. Leave the plus sign between. And in the second parentheses, put a 21t plus 15. First parentheses, between 7 and 5, there isn't a common factor other than 1 to worry about, so I won't do a common factor there. But both terms have a t. I'll take the smaller exponent and factor out a t squared from the first parentheses. Take 2 t's away from each piece. The 7t cubed, when I take 2 t's away, I'm left with a 7t. Not changing any signs because I didn't factor out a negative. And from the 5t squared, when I factor out a t squared, I'm left with a 5. Bring down my plus sign. Second parentheses, I'm going to factor out a 3. 3 is the biggest number that goes evenly into 21 and 15. And in the second parentheses, the second term doesn't have a t, so I can't factor out a t. So I'm going to factor out a common factor of 3. First term, I'll do 21 divided by 3 and get a 7 and leave the t. bring down the plus sign because I didn't factor out a negative. I'm keeping the signs. Second term, factor out a 3. So in my mind, I divide the 15 by 3 and get a 5. Then I'm going to write common parentheses followed by what's in front of the common parentheses. But there isn't any reason that that's the only correct answer because these would be equally correct. So a magical one-part video. I feel like this is enough that, I didn't do as many problems as I might naturally do, but I feel like, they're very repetitive. I think once you get the techniques of making the 2 parentheses, factoring out the negative when you need to, if you can factor out with common factors, then I hope it's not so bad. So I'm going to stop the video and just make this a part 1 of 1.